Really helpful. Someone asked me a question over the weekend and I was able to answer it with a video. So if you have a question you're working on, whatever, you don't have to wait till Monday. You can ask me right away and I can first I'll communicate with you by text or phone to figure out if I can resolve whatever it is with you personally. But if I feel like, oh wow, this is really important, I need to communicate this to the entire class, that's what's nice about it. It can deliver the whole thing. So I don't know if you saw the teal answer to questions that somebody had, but I think it was exactly about that, converting to sines and cosines. Were you able to see that? It's on the videos. It was just called extra help, so I'll be posting those extra help ones.
That was really helpful because I was going to text you because I didn't understand how to do the Bible.
Right. Sometimes it's all about communication. I know they always say that about relationships, that it's about communication, but it is about communication, right? If I stand here and yap and have a party by myself up here, I'm just having a math party by myself. But unless I get the feedback from you, I'm really not going to know where the gaps are. I can make assumptions, but I'm not going to know. So the questions to me are really helpful because they help me know, and I like to help before it gets too late, so that's a nice way to deliver the whole thing. Another thing I do is if you're doing your work and you don't know the next step, but you have pieces of the steps, you can take a picture of your work and text me the picture and say, I got up to this step, I have no idea where to do the next step. And then if I need to, I can take that picture into Microsoft Word, make some changes and email it to you. So that's another way that we can communicate one-on-one and personalize the direction. And if it's something really valuable, then the whole class can see it as either a video, or I can send it out to everybody by email and say, look, you might be having trouble at this step. So I think the one you might be, was it this one where you're changing? I did this one, right? I did this one in class. I did these in class, and I think I did it on the teal video again because somebody had more questions, so I did it more slowly and carefully. Was it this one?
Yeah.
I did this one in class too.
So I have a question. How many questions are we going to have recorded?
I always make it so it's about 20 minutes, so I have a pretty good idea. So I don't make the number, I kind of lot the time.
Is this like PowerPoint on the last page?
No, this PowerPoint's not on there because I like to vet it out with you guys. If there's a mistake, I like to fix it or put a comment under the YouTube videos in case there's any errors. So did I do this one in class? Okay. Let's do one more in class, and then I can review the teal video thing with you guys one more time so you can see it. So here it's state whether this equation is an identity, and then you stop me, Kelsey, not Chelsea, Kelsey, stop me if you have questions along the way. The first step is you have to break the entire thing into sines and cosines because it's almost like they're looking at everything with other versions. You can't tell whether something's equal until you have everything expressed the same way. So the first step in everything is to break down things in sines and cosines and combine them. So in this previous step, this already on the left-hand side, you're trying to show the left-hand side is equal to the right-hand side. So you already know the left-hand side is already in sines and cosines. So you want to combine those two fractions. That's the next step. I broke this down step by step before. So you want to combine them. And to combine them, you have to look at the denominators and ask yourself how the denominators are different and how can you make them the same? Because the left side is a fraction. So on the left side, the cosine on the bottom is missing the entire 1 plus sine. And the 1 plus sine is missing an entire cosine. So the first step is to make them the same by multiplying on the bottom exactly what was missing. So the bottom of the first expression was missing the 1 plus sine, so you put it there, but you have to put it there on top and bottom. That's how you get a common denominator. And the right side is missing a cosine, so you put it there on top and bottom as well. And now the denominators are the same. And that's how you get a common denominator. When my son was first learning how to add fractions, With numbers, his teacher would tell him, these tricks to add fractions. And I was looking at him, he's my experiment that I have at home where I can go, okay, I know you have to get up to here. So how can I make sure you're strong every step of the way so you can get up to here? It makes your life easier as you're going up. Because the stuff at the bottom is not that bad. It's the stuff at the top that gets hairy and scary. So what I realized is those tricks were actually going to keep him from doing stuff with algebra and trig functions one day. So I told him the whole object of the game is to make those denominators the same. And then what you're trying to do is to multiply top and bottom to make the denominators. That's the fundamentals. Just like when you're playing basketball. You have to learn to dribble well before you actually can do some tricks. And so that was my issue with him. And we fixed it along the way and made sure that he was doing things using fundamentals, good fundamentals. Okay, so the left side, so my point with that is, with the numbers, if you do it right with the numbers, do it the long way, no, don't use tricks, then when you come up to scary things like cosines and sines, it's not so bad. The procedure is exactly the same. So the left side, the way you combine those fractions now is that the denominator stays the same, and yet just add the numerators together. So that's what I did. I just lumped the numerators together. And now I'm going to do some high school algebra. I'm going to start pulling the sign in here. So I'm going to use the distributive law to take the sine x times 1 and add the sine x times sine x. Like so. So I think I tell you with those arrows that I use the distributive law to pull that together. If you sit like that, you might fall asleep. I already told you it was a boring lecture. I'm warning you. I used to teach at the military academy, and they were not allowed to sleep. I had to make them stand up if they were sleeping. So you know who the boring professors were there because their entire class was standing up. You'd walk past the windows and see that entire class stand up. Maybe I should make you guys do that. If you're falling asleep, just stand up. It's good for you. Standing is better than sitting for your health. So I'm looking out for you. Okay, so what I notice here is I have a sine squared plus cosine squared. And most famous says that's 1, right? Sine squared plus cosine squared is 1. So instead of sine squared plus cosine squared, I'm going to replace that with 1. And now I have sine x plus 1 on top. But see, these two things are the same on top and bottom, sine x plus 1 and 1 plus sine x. So they cancel out. And now I don't have anything on top, but I really do, because that top part is really multiplied by 1. So the 1 is still there on top. So I have 1 over cosine x, which is secant x, which lo and behold is the right side. So it's true. It actually does match up. So the whole purpose of this problem is to prove that the left side is equal to the right side. And this procedurally tells you how to do that. Step by step. Step 1 is always change everything to sines and cosines. Step 2 is to add anything or combine anything that's on the messy side using common denominators. And somewhere along the line, you probably have to apply sine squared plus cosine squared is equal to 1, because it seems like you always have to do that.
Are there more rules with the square? Because I know there was like the 10.
Right, and I show you in terms of, in the previous problem, you saw, some of the previous stuff you saw, I used that. I think this was one where I used that. Let me back up. Yeah, here's one. So this is on a previous problem. So since I already covered this, I'm going to use my hands. All right, so this is the only one I have to remember. And the reason I tell you that is because in higher level classes, or, I don't know what your major, bio. In bio, if you ever decide to take like physics, they might want you to know these things. So this one, sine squared plus cosine squared is equal to 1. You're never going to forget that, right? Because it's most famous. And you're going to give your boyfriend something for Valentine's Day this year that says, I'm sine squared, you're cosine squared, together with me 1. idea, right? Just save it for a different Valentine's Day. But so you never forget it, because I just told you something weird. And once you learn something weird, like, you never forget it. How do you get all the other ones? Those you might forget. How do I know you'll forget it? Because I have loads of Calc 1, Calc 2, Calc 3 students that never remember it. How do you get to the other ones? Well, you just take the original famous one and divide by sine squared here. Why did I divide by sine squared? Because cosine divided by sine is cotangent. And that's the red list. Remember the red list? So that's off that red list. I have to know cosine over sine is cotangent. And the thing I have has cotangent in it. That's why I took this famous identity and then divided through by sine squared to get this. And when it reduces down, I get 1 plus cotangent squared is cosecant squared, which over here now I can replace with cosecant squared. So that's how I've been getting around it, and that's why I'm showing it to you this way, because I have data showing me that students don't remember the other ones.
Is it the same squared and unsquared? Like if it's cosecant over sine, would it be different?
Right, if you needed the other one, like the one with secant squared in it, you would divide through by, instead of dividing through by sine squared, you divide through by cosine squared. And I believe I did one previous to it that was just like that. Yeah, here it is. See this green? The green happened first. And then I look up there at the top. I have tangent squared x plus 1. How do I know that's secant squared? Well, I took most famous and divided by cosine squared, and you get tangent squared plus 1 is equal to secant squared. What I've seen is if students commit that to memory, they get the 1 in the wrong spot because they mix it up with most famous. But in the upper level classes, they always remember the most famous one. They forget the other ones. Is it clear how to get from one to the other?
But when I did it just now, I see you cop plus 1 equals secant.
Right, if I divide it through by sine squared, I'll get that one that you just mentioned. If I divide it through by cosine squared, I get this one. See, sine over cosine is tangent. This is 1, this is 1 over cosine secant.
So, oh no, that's about this one. That's my other one.
Yeah, the other one I needed a cosecant in it. So if I divide this green by sine squares, I'll get the one you just
Okay,
mentioned.
that's what's
Right.
When I looked at the multiple choice, I didn't see what I got.
That's scary, right? That's always scary when you don't see what you got. So let's see what happened. It is. It's the one with the key.
Oh,
See, right there.
so we don't look for one first, equal to
Yeah, what it's equal to, that tells me that that whole mess is equal to cosecant squared. Mine has a key by it because that's how mine looks like. So yours won't have a key by it until you make a lot of mistakes, then it will show you the answer.
I'm sorry, but how
Let me back up here. So I did the first, like I got up to this step, right? And I get cotangent squared x plus 1. And like Kelsey was saying, I know there's some kind of other rules that I'm supposed to remember that's above and beyond most famous. One of them has a cotangent in it. I just don't remember what it is. So what we do is we go back to most famous, which is sine squared plus cosine squared is equal to 1. How do I get a cotangent from that equation? Cotangent is cosine divided by sine. So I'll have to divide everything by sine. And that's where I get it. So 1 plus cotangent squared is cosecant squared. So the black stuff is equal to cosecant squared, which is answer number 1 on the list. Which makes you feel pretty good, right? The worst feeling is when you don't have the answers in the multiple choice. No, the worst feeling is not for Webassign. The worst feeling is when you're on a test that's multiple choice and your answer's not there. That's the worst feeling. And the worst feeling is if it's the driver's exam.